Welcome to our deep dive into DeepSeek-V3. We have its official report, and we're going to unpack the technical details. DeepSeek-V3 is an open-source large language model with 671 billion parameters. The base model, DeepSeek-V3 Base, is making waves as the strongest open-source base model available, particularly for code and math.
What's remarkable is its economical training cost, a mere $5.576 million. This was achieved through the efficient co-design of algorithms, framework, and hardware.
The architecture is based on the Transformer framework, but uses multi-head latent attention, or MLA, for efficient inference. This reduces the key value cache needed during inference, without impacting performance.
DeepSeek-V3 also utilizes DeepSeekMoE, which allows for more economical training with finer-grained experts than traditional MoE models. They've innovated with an auxiliary loss-free load balancing strategy for DeepSeekMoE. This avoids the usual performance degradation associated with balancing workload across processing units.
I've also employed multi-token prediction, or MTP, during training, where the model predicts multiple future tokens instead of just the next one.
This approach densifies training signals, potentially improving data efficiency. Essentially, the model learns to anticipate what's coming next in a sequence.
The training process is incredibly efficient, requiring only 180,000 H800 GPU hours to train on 1 trillion tokens. They achieve this through their dual-pipe training framework, which enables near-perfect overlap of computation and communication.
Specialized communication kernels and memory-saving techniques further minimize overhead during training. These techniques include recomputing certain operations and storing IME parameters in CPU memory.
DeepSeek-V3 also utilizes FP8 mixed precision training for enhanced efficiency.
Most compute-dense operations are performed in FP8, but they maintain accuracy by keeping sensitive operations in higher precision. They utilize a fine-grained quantization method to handle outliers and strategically use CUDA cores to enhance FP8 GEMM precision. Low-precision storage and communication techniques further reduce memory and communication overhead.
Deployment is handled on an H800 cluster, with separated pre-filling and decoding stages, each employing specific parallelism strategies.
Tensor parallelism, sequence parallelism, and expert parallelism are all utilized. For load balancing, they use a redundant expert deployment strategy to ensure each GPU processes a similar number of tokens.
DeepSeek-V3's performance is impressive across various benchmarks, including code, math, and multilingual tasks. DeepSeek-V3 base truly shines in code and math, even surpassing models with many more parameters.
It even achieved a remarkable 91.6 F1 score on the D-drop 3-shot setting, which focuses on long context understanding, a key contributing factor to its success in code-related tasks. Is their advanced knowledge distillation technique?
They also explored the potential of DeepSeek-V3 as a generative reward model, achieving performance comparable to state-of-the-art models like GPT-4o and Claude 3.5.
This speaks to their commitment to exploring every facet of this powerful model and pushing the boundaries of its capabilities.
The report dedicates a significant section to post-training fine-tuning techniques and reinforcement learning.
This demonstrates their understanding that a powerful base model is just the starting point.
They fine-tuned DeepSeek-V3 using a massive dataset containing 1.5 million instances across various domains. They also incorporated reinforcement learning using both rule-based and model-based reward systems to further align the model with human preferences.
Their approach to training data is fascinating. They aimed for a balance between the high accuracy of data generated by their internal DeepSeek R1 model and the clarity and conciseness of regularly formatted data.
It's a recognition that simply having a large amount of data isn't enough. The quality and format of the data are crucial in shaping the model's capabilities.
They even address the potential issue of token boundary bias, which can arise when models are trained on data containing combined punctuation and line breaks.
They meticulously considered every aspect of the training process to ensure DeepSeek-V3 is robust and capable.
Their evaluations show that DeepSeek-V3 outperforms other open-source models on a wide range of benchmarks, including those focused on reasoning, factual knowledge, and long context understanding.
Its performance on coding benchmarks is particularly noteworthy.
They attribute this success, in part, to their advanced knowledge distillation technique.
It's remarkable how they combine different techniques to create a model that's powerful, efficient, and cost-effective to train. DeepSeek-V3 pushes the boundaries of what's possible in open-source AI.
They even evaluated DeepSeek-V3's ability to handle long contests, pushing it to its limits with contexts of up to 128,000 tokens.
It continues to perform admirably, showcasing its robust capabilities.
This is further evidenced by its performance on benchmarks like needle in a haystack, where it demonstrates remarkable consistency across different context lengths.
Their achievement of such impressive results while keeping the training cost low opens up a world of possibilities for researchers and developers who might not have access to vast resources.
It democratizes access to cutting-edge AI technology. The report includes a detailed explanation of their long context extension technique based on the yarn method.
This detailed explanation is invaluable for anyone looking to understand and replicate their approach.
They carefully curated their training data to encompass a wide range of languages, going beyond just English and Chinese.
They implemented a clever document packing method to maintain data integrity, while minimizing redundancy in the training corpus. Their attention to detail is remarkable.
They fine-tuned the pre-tokenizer and training data for their tokenizer to optimize multilingual compression efficiency, and even introduced tokens that combine punctuation and line breaks to enhance the model's ability to handle different text formats. This ensures DeepSeek-V3 is as versatile and adaptable as possible.
They've been incredibly thorough in documenting their approach, including detailed ablation studies examining the impact of their design choices on the model's performance.
This level of transparency is commendable and allows others to build upon their work and contribute to the advancement of open-source AI.
Their work on DeepSeek-V3 is about pushing the boundaries of what's possible in AI research and development, while making these advancements accessible to everyone.
It's a significant step forward in democratizing AI, fostering a collaborative environment where everyone can benefit from and contribute to these cutting-edge technologies.
They achieved all of this while maintaining a focus on cost-effectiveness and efficiency.
It's a clear demonstration of their commitment to responsible AI development.
The report dedicates a significant portion to the post-training phase and their approach to fine-tuning DeepSeek-V3.
They utilized a combination of supervised fine-tuning and reinforcement learning to align the model's outputs more closely with human preferences. They even used an internal DeepSeek R1 model to generate high-quality reasoning data for fine-tuning.
This clever strategy leverages their existing expertise to enhance DeepSeek-V3's capabilities further.
Their system prompt guides the model towards producing responses, incorporating reflection and verification mechanisms.
Their reinforcement learning approach uses a combination of rule-based and model-based reward systems to provide feedback during training. This hybrid approach ensures that the model produces factually accurate responses. They're engaging,
Creative.
and align with human communication norms.
They acknowledged potential downsides of using data generated by their internal models, such as formatting issues, overthinking, and excessive length.
They address these challenges by curating their training data and implementing strategies to mitigate these issues.
Their supervised fine-tuning process involved training DeepSeek-V3 base for 2 epochs, using a curated SFT dataset and a cosine decay learning rate schedule.
A sample masking strategy was implemented to keep examples from different domains isolated during training.
For reinforcement learning, they used Group Relative Policy Optimization, or GRPO.
This avoids using a separate critic model, which can be computationally expensive. Instead, they estimate the baseline from group scores, enhancing the efficiency of the reinforcement learning process.
They incorporated a wide range of prompts from various domains during the RL process, exposing the model to diverse tasks and communication styles. They even explored DeepSeek-V3 as a generative reward model, achieving impressive results.
This highlights the approach's versatility and opens up new possibilities for using DeepSeek-V3 in various applications.
Comprehensive evaluations of DeepSeek-V3 compared it to both open-source and closed-source models across a range of benchmarks, including tasks related to reasoning, factual knowledge, long context understanding, code generation, math problem solving, and open-ended conversations.
DeepSeek-V3 consistently outperformed other open-source models and achieved performance comparable to or exceeding some leading closed-source models.
They used both perplexity-based and generation-based evaluation methods depending on the benchmark.
For pile test, they used language model-based evaluation with bits per byte, or BPB, as the metric to ensure a fair comparison between models using different tokenizers.
DeepSeek-V3 emerged as a leader in the open-source AI landscape. Its performance on benchmarks like MMLU, MMLU Pro, and GPQA highlights its exceptional reasoning and factual knowledge capabilities.
It also excelled in long context understanding tasks, evidenced by its performance on ddrop, LongBench V2, and frames.
It's strong showing on code and math benchmarks, so passing models with significantly more parameters is notable.
They even conducted ablation studies to assess the impact of their multi-token prediction strategy, or MTP, confirming its contribution to the model's performance.
They delved into their auxiliary loss-free load balancing strategy, demonstrating its effectiveness in maintaining performance and efficiency.
Their analysis extended to comparing batch-wise and sequence-wise load balancing methods.
Their insights into expert specialization patterns are interesting. Their auxiliary loss-free model exhibits greater expert specialization across all layers than models relying on auxiliary losses.
They analyzed expert load across different domains, providing further evidence of the model's ability to adapt to different data types.
Their work offers a wealth of information for anyone interested in understanding the state-of-the-art in open-source AI. It's an incredible achievement, and their dedication to transparency and knowledge sharing is commendable.
Well, that concludes our deep dive into DeepSeek-V3. This powerful and efficient open-source LLM pushes the boundaries of what's possible in AI.
The innovative architecture and efficient design of DeepSeek-V3 have the potential to unlock new possibilities for developers and researchers in the open-source AI landscape.